So
course.
we are now at the magic hour of 2 o'clock. So we're again. I'd like to thank everybody for joining us for today's webinar, celebrating 40 years of TMS as role in safety and innovation. It's our 40th anniversary of the company being founded, and I'd like to thank you all for joining us and share a few stories with us today about what we've done over those 40 years, and specifically give you some content in relation to airfield lighting, test and inspection, which of course is our core role in life. So as usual, we have and today as a lead presenter, Tony Smith, the world-renowned inventor of the PAPI, a lifetime in aviation, and he will be telling us, sharing some of his stories from said lifetime. So thank you for joining us today, Tony. Seward is joining us from upstate Connecticut. Is that?
No, upstate New York.
Upstate New York, where he's on his boat and kindly joining us, and will be participating with his knowledge and experience, based again in a lifetime in the industry, as one of our panelists. Unfortunately, Carl Johnson can't be with us today. Keith today has just come back from Zambia, where he's been performing a training course, and just was sharing a story with us how somebody he trained many years ago is now managing Lusaka Airport, and there's another great success. And I think the contribution you've made to airfield lighting, Keith, is just immense. But it's not over yet. So I'm very much looking forward to your contributions today. And Keith and Nick has not been able to join us yet today from Kenya. Hopefully he'll be able to join us a little bit later. So today we're celebrating the birthday of TMS. Last week we celebrated 40 years of safety of innovation, 40th anniversary of the company. We had a few cakes and a cup of tea or two in the office, and this is a picture of the team that we took to celebrate the day. And as you can see, even the sun came out, which was rather nice. So that was a nice. I think it's important we mark these events. So how did it happen? Well, Tailor-Made Systems is now a small, it's relatively small, independent, employee-owned company founded in 1984. And it's very important when we talk about being an independent company. It means we're not aligned to, we are impartial. We're not. We work for the industry. We work for airports, for industry stakeholders, the installers, the lighting manufacturers, the regulators, but we're very much in an independent capacity, giving our unbiased support to the industry to help it become even better with safe, compliant, and efficient products and services. TMS, or Tailor-Made Systems, initially designed a range of products to service the requirements of customers such as the highway authorities, electricity supply companies, and others. This was back in the late 80s and still into the early 90s. And in doing so, it was rather successful. Won three UK Smart Awards in recognition of the quality and the innovative nature of its products and its MIMS mobile illuminance monitoring system. Now, this was a product that was developed to measure street lighting, and if you'd been around in those early days, you'd have seen a vehicle driving around Coventry with a sensor on the top, which we still have, by the way, in our office. And what it did is it drove around the streets at night. It would measure the light output in all the streets and produce a report that could, in the morning, be provided to the city engineer, who would then be able to dispatch his engineers to go and fix the lights, be they, put a new light bulb in or replace them, or however they did it back in the day. Now, this light monitoring system was featured on a British technology program called Tomorrow's World. And well, I don't want to steal Tony's thunder. Tony was there. Tony was very much part of this time with TMS. And so, Tony, if I could just hand over to you, perhaps you could share with us your experiences of your involvement with your early days involvement with TMS and the industry as a whole, and then I can bring it together with where I joined with Vernon and TMS at the Warwick Conference Centre back in 2008.
Okay, well, what I've prepared is really a bit of a history lesson on the basis of my involvement over these years in the developments that we're celebrating today. Just very briefly, my background is that I'm a physicist by profession, as it were. Studied at what is now City University London, applied physics. That was my background. I'd always been interested in aeroplanes from a boy. I loved them, and I also liked doing experiments. And I found a job fairly local at the Royal Aircraft Establishment, Bedford, which is about 60 miles north of London, an internationally known, with high repute research establishment belonging to the government. So I was employed as a government scientist all my working life in Bedford in various capacities. I started life in the area of landing aircraft, fixed wing fighter type aircraft on aircraft carriers. That's where I started. So I spent quite a lot of time with the Navy and a lot of time at sea. After initially joining as a very junior scientist, began to specialize in areas to do with aids to the pilot, what the pilot could see to help him land in that very difficult, challenging environment, landing on a small pitching deck day and night. One of the things I got involved in was looking at the possible use of head-up displays, which were very new then in 50 more years ago. And I think the colleagues I work with, we were the first people in the world to show that you could use a head-up display as an approach and landing aid. We also looked at the visual aids, the lighting side of it, involved in that. And then that work came to an end in 1970, and I moved across the airfield to another laboratory area, which is housed the Blind Landing Experimental Unit, whose job was, in those days, to be in the forefront of driving forward the development of all-weather operations, both for military and civil, to get eventually to a 0-0 landing, an automatic landing. And that was a long process with a lot of detailed work in all sorts of areas, but including the visual aids to support the landing and takeoff operations. So I joined that and started then to focus on visual aids. And the first area I got involved in was a requirement that we were studying to look and be sure that the lighting at airports, particularly in the UK, was going to be adequate for the new range of larger aircraft with different fields of view. In other words, the Concorde and even more so the 747, which are going to come into service very shortly in the 1970s. So I started work looking at a good place to start is, well, what have we got at the moment and how is it working? And I went out onto airfields with a photocell and started measuring light outputs, and was absolutely appalled and amazed that I was going to airports that had been flight tested, that wonderful phrase, flight tested possibly only the week before as being compliant with the requirements. And I was finding light outputs on the centre line, for example, where I was expecting to find 5,000 candelas. I was finding regularly less than 500, and in some cases only 200. And a similar thing on the taxiway. The lighting was often less than 10% of what it should be. And this was due down in practical terms to contamination of the projection systems, water ingress, dirt, whole lot of things. That resulted in me producing a report which went to the Civil Aviation Authority, our regulator, saying this is the situation, without naming airports and making them criminals, as it were, but to say there's a real issue here. And I continued to push that, as I did other things with the Civil Aviation Authority, because we did research both for the military and the civil. There was a lot of commonality in this area of automatic and low visibility landings. At this time as well, there was another project which was to not only look at the output of the taxiway lighting, which we knew would need enhancement in intensity and beam spreads, but also the approach and runway lighting. And made considerable studies and convinced ourselves and then those who we were doing research for that what was needed was particularly greater vertical beam spread in the approach lighting and the runway lighting to cope with category 2 and 3 operation. The reason being that in category 1, which was what the lighting was designed for and ICAO had, was only actually designed for visibilities of greater than 800 meters, half a mile, and a cloud base of at least 200 feet. In those circumstances, if you're going to make contact with the lighting, it's well before you actually get to the approach lighting. You see, it's out beyond the cockpit combing. Category 2 and 3, increasingly, your first contact is going to be when you're over very close to and over the approach lights, and your downward view is where you're looking to see them. In those conditions, is literally looking at the cockpit combing and saying, looking for a light there, not looking out ahead. That means a greater vertical beam spread required on the lights. To demonstrate that, I devised an experiment where we went flying in fog, where we amended our lighting at Bedford so that the approach lights, and using the Calvert pattern of 5 crossbars, the right-hand crossbar, I increased the setting angle by 3 degrees and did similar things on the runway center line, but left the left-hand crossbars of the approach lighting on the old category 1 settings. We went fog flying, and I wish I'd still got it. The classic was a lovely piece of film which showed an approach in category 2, 3 conditions, where it was just looking at grayness, and then suddenly lights appeared at the cockpit combing, but only on the right-hand side, the one that had been elevated. The left-hand side, no lights. The approach continued 500 feet near the runway. Another crossbar came in on the right-hand side, nothing on the left-hand side. And it wasn't until we'd gone another 500 feet, another total distance of 1,000 feet, before we saw anything on the left-hand side, which demonstrated quite convincingly we needed more vertical beam spread. And that was fed through 1976 to the ICAO Visual Aids panel, which I attended for the first time. What we have today in Annex 14 as a result of that, the beam spreads and setting angles. Out of that comes a very good illustration of why we need to maintain lighting to the specifications, both in terms of intensity and setting angles. If you consider what I was doing, I was increasing the intensity in the vertical. And if you look at the isocandela diagrams, I was at least doubling, if not tripling, the amount of light at the angles that the pilot would actually be looking. In other words, it's the difference between 100% and 50%. So, 1,000 feet of approach, right? That's 50 feet in height. That makes an enormous difference to your contact height. See how critical it is if you haven't got the right intensity. 50% could result in you getting a decision height in category 2, 50 feet lower than it should be. So I think that clearly emphasizes how important it is to get this output right. You have the intensity and the setting angles, the whole beam spread story. So that told us quite a lot. And I continue to hammer on the door of CAO and say, look, one of the problems I found was that the maintenance staff had got no idea what they were doing in terms of how important it was to maintain according to the book values. Their criteria was simply go out onto the runways at night and find lights where the fitting was not emitting light, and usually change the light bulb, occasionally change the fitting, and that's the only guidance they had. And that resulted in this performance. They had no idea how much it was underfoot. They got no test equipment. They hadn't got any means of measuring what they were doing. And it took quite a long time, but eventually the CAA, they had a new desk officer came in, ex-pilot, well qualified with an engineering degree. We talked, he understood what I was saying, and he said, well, I'll start a research project to address this issue because it's important. And they put out a project request for someone in industry who would research and develop something based on some prototypes that I'd actually made at Bedford, with slides just demonstrating the principle. And they found tailor-made systems and gave the contract to tailor-made systems and appointed me as the technical officer supervising with tailor-made on their behalf that research. Hence the beginnings of MARMS with Vernon Taylor, who then was at the helm of TMS. And over a number of years, the system, largely as it is today, the trailer system was developed to, first of all, runway centerline lights, and then expanding to edge lights and touchdown zone lights, but also importantly, taxiway lighting. During that time, one of the things that came out of the work as the data became available, TMS were able to show they used the Birmingham International Airport, fairly near their headquarters in Coventry, as a test bed. They were very willing cooperators. And Vernon was able to demonstrate after some development that by using the trailer, they could bring the lighting performance, which was previously down at the values that I had found, well below anything like the specification. They could bring the whole of the approach, all the runway lighting and the taxiway lighting, something quite close to the specification by highlighting where maintenance need to be done, targeting maintenance in the right places. As a result of that, we were able to go to the visual aids panel and say, look, this needs to go into the aerodrome design manual, a whole chapter on the need to have this monitoring, and that if you adopt this approach, do some actual measurements in field, capture the data, respond to it. Not only will you get lighting that is very close to being, if not totally compliant, certainly up in the very high percentages of light output the whole time, all the time, and but also in doing it, what the airport then reported was it was actually costing them less, significantly less, to do their monitoring than using their old methods. So it was a win-win situation. So that is why, if you like, that's why we have the trailer system that you saw a picture of in the beginning of this presentation. It was a classic example that illustrates the truth of those words. You can't do any maintenance if you can't do your monitoring. You need to monitor and measure. And this, what I would say in that context, because it was so appalling, before we could actually develop this work, at a visual aids meeting, which I attended with the CAA, we proposed that at least ICAO should say your lighting must have an output of 50%. If it isn't, then it's unserviceable. we didn't believe 50% was the right value, but at least it's the first attempt at giving the maintenance people something to aim at as to what they should achieve. And of course, that was quite a long way from where they were. But the intention was, both in the UK and in the visual aids panel, that as we got more data and the project developed, we would get to the situation where effectively then TMS was showing to get to, where we could get lighting that was compliant. Unfortunately, ICAO has never really addressed that follow-on work in terms of putting numbers in the way that was envisaged. There's a lack there still on the regulatory side, but without this sort of system, you'll never, and the training that goes with it, adequately trained stuff, you're never going to achieve those values of output, which I think were my illustration of the vertical beam spread, how the doubling of it gave a 50-foot height increase in contact height in low visibilities. How important it is to have the right, those specified intentions there for a purpose. They're not just a good idea of this is the best we can do. They are the absolute minimums that are necessary for safe and regular operations. So we had the mobile measurement equipment by the late 80s and through the 90s, saw its development presented to the visual aids panel in the 1990s, and I think it's chapter 14 in annex in the aerodrome design manual. There's a whole series of data on that, how to do it based on, in fact, the MARM system. Whilst we were doing that work, incidentally, we had a visual aids panel working group meeting in Japan. And we had quite a surprise as a working group when we were taken to Narita Airport by the Japanese hosts and taken to their maintenance area, the workshops. When we arrived, the first thing we had to do was take our shoes off and put slippers on. The floors were all painted and shiny, like inside a hospital. And we were shown laboratories where there seemed a large number of people doing maintenance on light fittings, and then they were being recycled and put back on the shelf, and they'd got a system in operation so they could draw them on. There was a lot of professionalism, and you can see. We asked about the staff. One thing they said, well, we've got a staff here that includes 24 graduates doing this work. We were working, certainly in the UK, on electricians who weren't good electricians, but certainly were nowhere near that level of ability and expertise. And that was a bit of a shock to see what the Japanese were doing, and they were looking at in measurement actually out on the airfield as well, so that maintenance is based on in-field data. So that, in a way, is very much the basis of MARM's TMS. But a few other things I'd like to say, I think, really. I've mentioned in what I was saying a few minutes ago about beam spreads. I think it's important to say, not only does MARMS measure, if you like, the intensity, which most people tend to take, well, it's the intensity in the middle of the beam. They measure the extent of the beam, parts of the beam that are significant for the operation, what the pilot will actually be looking at various stages of the approach. And so it's important that that aspect is covered, not only just basic intensity, but the intensities in the beam spreads. In other words, the isocandela diagrams, which, if I might say so, are in Annex 14 because I insisted that we had a proper specification for the lights, not just saying what the peak intensity was, and what the intensity was at half peak, which is how it was in the Annex 14. But that we, for all the lights, we had a proper isocandela diagram produced, and Annex 14 was amended some 20-25 years ago now to specify the lights for the beam spread. In the testing that is done today with equipment like MARMS, its setting angles are an increasingly important part. It isn't just the basic intensity in the middle of the beam. And standards, as I say, were changed in terms of approach and runway lighting in the late 1970s, actually at a meeting where it was adopted based very much on the work they'd done at the RA at Bedford, with one other input from the doyen of American US lighting, the old Charlie Douglas, who was the chairman on the visual aids panel, and his inputs on behalf of the FAA. We came up with a specification which actually went into operation after a meeting in Montreal in deep snow in February 1976. And those specifications, I believe, serve the industry well, provided what is actually installed in the runway achieves those values. And so, drawing to a conclusion and handing back to Robert, just want to say that the good thing that I've seen with TMS in recent years, having, if you like, established the basic requirement for photometric work, the runway and taxiway lighting, they've developed their capability to cover other important areas like the signage and the PAPI, which is other things that the specifications, that was another area on behalf of our CAA and ICAO. We did research at Bedford. The signage system was developed through the ICAO Visual Aids panel by research we did, and some of the research you might be interested just to know. We looked very carefully at the size, the color, and the font of the letters and everything like that to do with signage, to get something that would be unambiguous and would be a contributor to reducing runway incursions when pilots not know where they are. The feedback I've had over the years is that what we developed was a big improvement. But there again, the intensity or the luminance, in this case, not the point intensity, but the luminance of that those signs is important, as indeed is the size of the sign and the size of the letters on the sign. One data point we worked with, for example, we assumed that a pilot would need to see a sign for 10 seconds before he actually reached the junction. That's the time to find the sign, understand what it says, and be situationally aware of what it was telling him. 10 seconds viewing distance. We assumed a taxi speed of 30 knots, which is not unreasonable in many conditions, not in low visibility. But that, if you do the sums, then you come out with the size of sign and the overall design, which meets that criteria. So the signs can be read the appropriate distance. Of course, in low visibilities, you've still got an intensity. You won't necessarily see them 10 seconds ahead, but then you're taxiing much slower. And the lowest visibilities, it might be as low as 5 knots. But the signs still play their important part there. And finally, more recently, feedback from early webinars in this series had shown that there was a real need for help in setting up and maintaining PAPI systems. And I'm sure Robert's going to talk a bit more about that as one of their products. I think that's making a very positive impact into the industry now that we have an equipment to do that. Also finding some rather dark areas in various aspects of PAPI implementation, which is being drawn to the attention of various people. But PAPI needs to be properly installed.
You don't need the work order stacks.
Which is
No.
well, I think that is a canter through it. I hope, Robert, that's what you were looking for, and perhaps back to you now for you to carry on with your part of the input to this discussion.
Right. Well, thank you, Tony. I will go back to the presentation, and so thank you very much. As Tony's explained, he played a key role in the evolution of tailor-made systems into its leading position as in developing test and inspection products and services specifically for visual aids for the aviation industry. So as you heard, Tony and Vernon and his team, with the support of Tony, the Civil Aviation Authority, and DERA, and the defence sector in the UK, all worked together to develop a photometric testing system. I first met Vernon Taylor in 2008 at an ADB conference in the Warwick Conference Centre, where they used to hold their annual lighting conferences, and immediately struck a friendship, which combined, and we decided to combine in 2009, and Vernon asked me to manage the joined companies, the EGS company Electronic Design and Manufacturing company that I was managing director of, together with TaylorMade Systems. And EGS at that time had an innovative torque wrench solution, which you can now recognize in our electronic torque wrench, the Airfield torque wrench, as that we brought together with, we're working currently with Heathrow and the British BAA to combine that with the products of TMS and focus on the aviation sector. So out of that, we continue to develop the products and services of TaylorMade Systems, and we orientated everything that was being done in EGS to focus on aviation. And as part of the development of the company, we had an annual user group, which we still hold today. Invited all of our customers to join us at a hotel somewhere in predominant, I think, always. I'm trying to think, has it ever not been held in the UK? We have had user group meetings outside of the UK, but mostly in the UK, where we conduct a day's meeting comprising an industry review, talking about the things that are affecting airports and the industry in general, looking at a regulatory update. Paul Fazer-Bennison would kindly come and join us every year and give us an update on what was happening in the world of regulation. We would have a mum's product update and demonstrations of products, and invite guest speakers to talk about related technologies for airports. And of course, a very important part of the meeting was the networking opportunity presented of getting so many airports together, where everyone could meet their peers, discuss common problems, and learn from each other. And that's continued to be a very, very useful format, and a very well-received format in the industry over the years. This led to product development, because rather than tell the industry what they should have, we always finished every meeting with a questionnaire where we ask customers, the usual questions about how they like the conference, how they like the presentations, what they wanted to hear about in future, but also what products and services they'd like us to offer in the future. And this is where our product evolution has come from. Right from the beginning, I was informed that MARMS having, tailor-made systems or MARMS as a one-stop shop for airfield lighting test inspection products and services would be viewed as very beneficial. Airports wanted to work with an independent provider, an independent expert who would give them the tools to help them with their safety and compliance, for their visual aids, the lights at the airport. And when they said lights, it wasn't just the mobile, just the pavement lights, the runway lights. This discussion moved on into taxiway lights, low intensity lights, and approach lights. And from that, we looked at, the discussions already taken to looking not just at in-field maintenance, but also within the workshop. Of course, as I said before, we'd brought from EGS the M-Torque solution, so an electronic torque wrench to provide traceability to the management of the tightening of bolts or nuts on light fixtures, particularly the inset fixtures at airports, following a number of high-profile incidents where lighting had come out of the runway and caused considerable damage to planes. So that was a highly, but when we were doing this, we were told, well, look, if you're going down the runway with a torque wrench inspecting the bolts, you'll notice other things, and you've got a tablet with you, which has a camera. Why can't you record more relevant information and turn it into an inspection system? Because we don't have to send somebody else down the runway to do the same job. And so MARMS Engineer was born, and we started to, and has evolved today into be the market leading CMMS, computerized maintenance management system, which supports an airport right the way from scheduling of preventive maintenance jobs to recording all of those tasks and activities, and then scheduling and recording any actions to address the problems, repairs and maintenance work coming from the inspections and other preventive maintenance actions. So that was where MARMS Engineer came from. Then, of course, we were working on the transverse device right from the very earliest days, because although we started off looking, I think, at center lines, there are other lights that are that run across runways. So you've got the approach crossbars, you've got the threshold lights, you've got the runway end lights, stop bars or runway guard lights in the US, and these lights need to be measured quickly and accurately. And the initial systems that we developed only allowed them to be measured one at a time, so it was very much needed given runway access has always been an issue in our industry, to be able to provide the tools to measure transverse across a runway, a taxiway, and an approach. And at this point, I should also mention that all of this product development is extremely time consuming and expensive, because when we develop tools and products, they have to be accurate. As Tony said, you cannot manage what you do not measure, but the measurement has to be accurate and reliable to be able to determine the correct course of action. There's no point in doing it if you can't get an accurate measurement. And so right the way from our initial product, the MARMS mobile system for infield measurement of runway centerline lights, as that product, as the torque wrench and MARMS Engineer and the transverse have developed, we've had to constantly use the changes in technology. As I think this industry standard perception is that processing power of computers doubles every 2 years, I think it is. Well, that processing power has to be built into our tools and equipment, because you need rapid. Time is of the essence when you're measuring on a runway, as we all know. Access remains the #1 issue for airfield maintainers in doing their job. So we had to build in the latest technologies. Of course, the technologies of the measurement systems, the right the way from the glass used to and the optics to be able to look at the lights and to record their performance, to the individual electronic components and as well as the mechanical components, which of course have evolved enormously over the last 40 years. So, and as you would expect, we've spent a lot of time constantly evolving and managing the improvement of those and engineering them into our solutions, so that you can have the benefit of them. Having developed the photometric testing systems, it became very apparent that the number one issue affecting the performance of the lights is lens contamination. The performance of the lighting we're looking to help support airports who do the maintenance at the end of the day with safe and compliant lighting, but we were constantly finding ourselves measuring filthy, dirty lights for all kinds of reasons, whether it's ice, snow, water, or rubber, which is one of the major contaminants, and as such, when we generate the results for that airport, it's not particularly helpful to the maintainers because they can't determine what requires maintenance beyond simply cleaning the lights, from a result that is largely dominated by failures caused by dirt on the lenses. So we've developed a range of cleaners now that support airports with maintaining the compliance of their lighting. But like every other bit of R&D, this isn't easy to do. Conceptually simple, but actually making something that is not only good at recording the work done and to help you manage your airfield lighting cleaning, but also it has to be quick and easy to use, robust and reliable, and well supported. And that's something we pride ourselves on here at TMS and have always done. The MARMS photo bench, which was the photometric measurement inside the workshop, that was one of the earlier products to be developed. Again, has evolved significantly over time as with the different development of new technologies, particularly from the early onset of LED lighting. We've had to develop the enhanced power supplies to enable all the different types of lights to be measured. And then all of the reporting and dashboard information to help support the analysis of the reasons for low performance. And therefore, out of that has come the dashboard and the key performance indicator reporting that MARMS is well known for with its cloud solutions, and now into the now with the now built into all of our products and services. The Sign and PAPI tester was one of the later developments, again asked for by you, and our customers first heard of it at the user group meetings. We've developed that, and I take my hat off to the unsung heroes of TMS who sit there and can come up with this incredible technology that can measure all the key components of in relation to compliance of both signs and PAPIs. There is nothing else like it on the market, and of course, and particularly with the challenges of a PAPI and the very concise precision that the measurements are required, particularly when we're talking about vertical angle and transition. I take my hat off to the team who've actually developed it, and again, thanks again to all my colleagues, especially Tony, who's provided, as you can imagine, a great deal of expertise to help us come up with something that, of course, measures accurately. Following on from that, we worked on a collaborative venture with Dublin Airport and have developed the Luxometer for measuring apron and stand lighting, and that's proved a great success in recent times. And finally, something I'm particularly proud of, when Keith came to me 3 or 4 years ago, just before COVID, in fact, to discuss the potential of working together on a training solutions provider. And now we're growing our team under the management of Kev, with Tony and Keith, of course. We now have a very strong team of trainers to support national and international training requirements for airfield lighting professionals. So I'd like to thank them all and the contribution they're making to airfield safety and compliance. So all in all, it's been a trip. Our products have evolved tremendously over the years. It's a process of continuous development, that as is necessary with technology, to ensure that we always give, we have a reliable product that gives accurate results quickly and is easy to use, and gives clear, concise reporting in the most intuitive ways, and particularly through the MARMS dashboard, which my colleague Rob and his team have been developing for us. But it's not just about the hardware products at TMS. We've also developed a whole range of software and services to actually support our customers. We offer test and inspection services across the world, particularly for newly installed lights, where we take our equipment and we measure, the lights, the signs, the PAPIs, the floodlights, to determine if they're compliant or not, and to provide recommendations if there are any issues. All that analysis is also brought to bear for smaller customers who don't have their own equipment. We can provide a service of regular monitoring and to support their maintenance activities.
Could I ask a question of you,
Yes,
Robert?
yes.
One of the things that you described, of course, you now have that ability to gather the information, you collect the information, you analyze the information, you present it. And what do you do with that information? Because I think Seward has been very involved in giving guidance to the industry, specifically, in his across the pond, as we call it, because when we're talking about performance, we've spoken about the 50%, which Tony has explained how the 50% came about. We're looking ideally at 100% light output, but the guidance for maintenance engineers. Now, Seward, you did a lot of work in this area, and this is where the 70% concept, when maintenance should begin. So from that aspect, Seward, maybe you could explain. I see you're still on mute like I was, but maybe you could explain how the 70% came about, because that's an important factor. What do we do with the information once we've got it? Eh?
That's correct, Keith. That's so important. And I want to thank Tony and Robert for that extensive presentation. And I can clearly say today that the impetus for maintaining a properly operating system has come from you guys over there. That has been the impetus. Now, back in the early days, I've been in this industry, and I can't believe it, but if I add it up on the calendar, it looks like 60 years almost. And but back in those early days, you mentioned Charlie Douglas, Tony. And we had some people who were in the FAA or worked with the Bureau of Standards who provided a lot of guidance on what we should do and when we design new fixtures. How should they be? What output should they be? And down through the years, we've agreed, because of all this equipment and procedures that you provided, to raise our elevation up. It must be a 70% minimum, 70% the minimum requirement set by the FAA standards, which is pretty much the same as ICAO, before they pass. So we've come a long way, but I grew up in a manufacturing facility, and I think for the years and years and years and years, there was no major emphasis from the FAA or from manufacturers to the importance of maintaining the systems. And so we have systems out there, like Tony mentioned, that they're very ill performing and that nobody cares. It seemed like nobody cared because we were more interested in producing products, selling product, getting together and talking about our ideas and our different products than we were maintaining the system. Now, maybe I'm a little bit blunt on that, but I think that's generally the way I see it and the way it's happened. And so we had a couple of people back through the years in our country that pursued the photometric evaluation of the fixtures, which never went very far. But we did have, and I taught 20 years for AAAE in a maintenance program, a maintenance training program for airport maintenance people. And that is one area where we finally get the message out to airports that you got to maintain the systems and there are minimum requirements. The FAA has put out a maintenance standard or advisory circular, as we call it, back about 10, 15, 20 years ago, maybe now, as to how you should maintain the systems, how you should maintain them. But this standard, as of today, is not being enforced by the FAA. And that's a blunt statement to say, but it is not being enforced by the FAA, and the FAA inspectors that come around and inspect your facility to see whether the light is on or off. That's about the extent of what they do many times. Is the light on or is it off? And that's a shame. But because of the training we've had in maintenance people through the years, there are a number of airports now that have the equipment to go out and measure the photometric testing or do the photometric testing. But it is a requirement that we do it bi-monthly, at least bi-monthly. And most airports don't own the equipment. Some do have the MELMS equipment, but then we have to get them do it on a bi-monthly basis. And we have to get other airports to involve themselves in the testing. And of course, thanks to MELMS, we have equipment available and they can hire it done at a particular time. But no airport hires it done every 2 months, like the FAA standard requires.
Are we really saying then that?
So I could go on and on that, but pardon?
The regulatory people should be have more information about what is available today, because it's the regulatory persons who check the airports and issue the license.
Well, yeah. The FAA does see a lot of documents that we write. They come to some of our meetings, and we have talked about the equipment we have available, but we still need that emphasis. And the emphasis today on the testing is coming more from the user than it is from the FAA, in my opinion. And so because we have been talking to users, we have had more emphasis. We are starting to get a realization of the need for an intensity which is acceptable to the pilot and gives the pilot safety. But we still have a ways to go, and we're right now working on trying to develop or trying to get the FAA to develop. For example, okay, it's all right to come out and test your photometric capability of your airport, but is the equipment you're using meet the standards for doing this? Does the equipment you're using meet the standards for doing the proper test and recording the correct data? We know that MELMS meets its particular spec, but we must know also that the FAA and all the agencies that specifying agencies must have standards, so we don't have other people entering this testing business with inaccurate equipment. And that equipment has got to be approved as such as sufficient for the job. And so that's another area which we're just concentrating on now. And we're trying to get the FAA to listen to this. And we're trying to get the users to listen to this, that everybody that comes along and may say, I can test your equipment. Can you really test the equipment to the standards the FAA has set? And we know the MELMS equipment does that because we do testing with it to know that it meets the standard. So I could go on. You asked a simple question. I gave you a complex answer. Sorry about that, Keith. But anyways, we have a great need to continue to educate the agencies that govern this product line that we're talking about and the people that use it.
Oh, thank you.
Well, thank you. It's a very comprehensive answer there. Thank you very much for that, as usual, for your contribution. And it's interesting. We have a question that is related to that from one of our participants has asked in the past, the UK regulator CAA, Civil Aviation Authority, has played a key role in sponsoring the research and development that leads to the successful development of products such as MARMS. What positive role should regulators have in 2024 and beyond? Any input?
Yeah, I'd like jump in on that one. I think Seward has just given us the magnum opus justification for why the regulators need to be much more proactive, you know, in other countries, and not only nationally, but I think ICAO, who thankfully do have a chapter in Annex the Aerodrome Design Manual, Part 4 on maintenance, but that needs supplementing. It shows an example of how you can do it, but there's no standard for the quality of the measurements, and this does allow people who can come onto the market and say, "Oh, we'll measure it for you," but you know, anything where you're doing this, you can't imagine in the field of electricity, you know, just straight electricity. You can't imagine there being on the market things that will measure volts and amps and whatever that are not up to a recognized standard, traceable back to national standards of measurement. And that's what we need in this area now. We need a specification for the mobile testing equipment, the specification for the PAPI tester. We need that, and the regulators should be playing a key role in leading that work. I have my doubts whether they will show the interest that CAA put into this 30 years ago, but that's what's needed. The regulators need to do, and I think it's reflected on what Seward said. The regulators need to be more upfront in demanding a proper maintenance system in all its aspects.
One of the aspects which I found, I've been very lucky to be able to travel the world, you know, to many airports around the globe, and the airports are becoming very aware of the requirement that the emphasis is put on the airport authority to demonstrate that their personnel and their equipment is fit for purpose in terms of competency. But when I request to meet the regulators in those countries, then I get complete silence, with the exception of a few, you know. So, and I think that demonstrates what we're talking about. Do the regulators really understand?
It occurs to me in this matter of equipment that is proper for the task that Seward raised a few moments ago. It gives me an opportunity to jump in and say one of my hobby horses, increasingly, is the uselessness of flight testing of equipment. The whole of this saga started in the 1970s when I went to international airports in the UK that had been flight tested by our regulator within the previous 2 weeks and given the all clear and saying they were conforming, and yet the light outputs were a fraction of what they should be. You know, a flight, how does your flight test measure whatever it is, whether it's your approach and runway lighting, whether it's your PAPI, how in your flight test do you actually measure intensity, beam spread, setting angles, and color? because
This
that's
is the four season AGL, Tony, yeah?
14. And
Yeah.
a pilot flying around with a stopwatch or something is incapable of doing any of that. So
Good.
if I could play, I'd say, for goodness sake, let us get rid of the flight test completely. It's a waste of time. It takes up a lot of airtime, actually. It rots up the approach pattern by this aircraft that wants to go round and round and round looking at the approach lighting.
I have another question which kind of have a couple of questions. I think, you know, from a pilot perspective, what is the significance of light beam spread for pilots during landing or takeoff?
You say it again, what was what?
What is the significance of light beam spread for pilots during landing or takeoff roll?
Well, I can give you an answer to that. In all of our work, one of my colleagues who worked for me in the section I led was he focused on the measurement of runway visual range. That was his real specialization. He really knew something inside out. Transmissometers, backscatter meters, all the various things. And he did some very innovative research to look at how one could mathematically model what the output of the lighting pattern actually gave the pilot in terms of what they would be able to see on the approach. His model required knowledge of the actual pattern. It needed a knowledge of the beam spreads of the lights being used and of all the appropriate setting angles. Then he drove his model and produced graphical data which showed the visual segment, in other words, how much the pilot could see on the approach as he approached, starting where he couldn't see anything to the point where it began to open out and begin to see approach lighting and then runway lighting, all the way down from initial contact to touchdown. So you'd have this profile of what could be seen. And we could play wonderful tunes on that. We could change the setting angles of the lights. We could change the intensity. And we could show that misalignments of a degree or two, which would tie in with what I was saying much earlier about setting angles, would make profound differences to what the pilot would actually see, and his ability actually to get adequate visual references before decision height, for example. It's a very powerful tool, and that is mentioned in the aerodrome design manual, mathematical modeling, and you can do it using various ways. You can design, knowing what you want to achieve, you can design the lighting. We actually did a study in the UK, because when London City Airport was going to be built, that was a 6-degree approach. There's no 6-degree approach lighting and runway lighting. We did a study in conjunction with a lighting manufacturer to show how existing equipment could be realigned and modified to produce the required visual cues. We were able to demonstrate that mathematically, and as that was done 25 or more years ago, as far as I know, London City is quite happy with the solution. So we actually designed a non-standard lighting system using this
Right.
modeling. So
I guess then, Tony, that would be very, very useful during your development of the PAPI, as we know today, and the angles. Of course, that kind of modeling would have been very useful to you. You know, when you eventually came up with the PAPI system to replace the VASI.
Yeah. Yes, well, the requirement there was to develop something for a project that a colleague of mine was running, looking at city centre to city centre concepts back in the mid to late 70s. you know, so that people didn't have a 20-mile journey out of city centre to get to their airport. The Canadians had a project with a -7, I think it was, between Montreal and Ottawa. They were actually doing flight testing. We did some studies, and we actually did a lot of approaches onto a simulated runway, because it was supposed to be a small runway and a steep approach. And the problem we had with doing that wasn't that we hadn't got aeroplanes that could do 6-degree approaches, but we didn't. The concept assumed an ILS approach at 6 degrees. There are no 6-degree ILSs. There certainly weren't 40 years ago, and no autopilots for flight. So the requirement was, how do we simulate a coupled approach down to 50 feet, which is specification, followed by a manual flare, with the same accuracy as you get if you could be coupled to an ILS. That's where PAPI came from. It was a tool to do an experiment, and in the PAPI report that we gave to ICAO, we showed that the coupling with the pilot flying it manually, the PAPI, was as good as being coupled to an ILS. Same accuracy.
Right. Okay. Thank you again, gentlemen, for those answers.
Can I
you
give one more
mentioned,
statement? Can I make one more statement, Robert?
yes, of course.
Yeah, what I wanted to say, I was very negative in my first go around there on standardization and checking it. But I want to say, in this country here, and the FAA does have very specific standards with regard to building the equipment, designing. They have very specific performance requirements. Now, the ICAO side, you may have just as specific, but the standards they have developed are very specific, and they, as far as we know, generally are very good in meeting the requirements of the fixture. The problem is after the fixture gets installed. But when the fixture is being designed to these standards, which we have input on, and gets approved, it's tested. All the fixtures are tested by independent test laboratories. We have 2 independent test laboratories which test the fixtures to make sure they conform to the performance specification as developed by the FAA. That part is pretty good. It's when we install the fixtures when we lose control. And I just want to give a compliment to the FAA in writing specific performance standards, and the fact we have independent test laboratories, 2 of them, which test every piece of equipment that goes out under the FAA performance criteria.
Yes, we
Thank
should
you.
appreciate the good things that are done.
Similarly, in the ICAO theatre, in the ICAO world, then is the IEC, the International Electrotechnical Commission, which produced the technical specifications for the equipment in the, shall we say, the rest of the world, Seward. So very, very similar, independent, non-negotiable inspections for the equipment. And as you say, it's when the equipment get out into that airfield in the operational theatre, then unless that there are specific, accurate tools to measure the light output, how the hell does anybody know? And yes, MARMs, there have equipment which are accurate. And I've had the opportunity over the years to look at all the different tools available in the marketplace, and clearly I have to say, yes, MARMS is a leading supplier of such equipment, and it can be demonstrated, justified.
Yeah. Can I just say something? The work Keith has been pioneering in MARMS, TMS, and the work Seward's doing, getting training for staff is so important. And that was one of the major problems, of course, when I started this. There was no training for essentially just electricians that have been recruited off the street. They weren't specialists in aviation lighting or anything. But all they knew was you change light bulbs when they fail. That was their criteria, and that's the only briefing they had. we need technicians who are properly qualified to deal with aviation ground lighting.
Well,
Properly,
it's one of the things, Tony, which an old colleague of mine, sadly has passed away now. He says, "This is my English mate, Keith. He changes the bulbs on the airfield," and I say, "Yeah, that's what I do." But we know it's a little different to that, don't we? Eh?
Certainly do. Right. You were talking earlier about the 4Cs. I heard you mention that. So, question here: how was the configuration regarding light spacings established for runway edge and centerline lighting, taking due consideration of the runway visual range, visibility conditions, for example, CAT 1, 2, and 3 operational conditions?
I think that's a question which comes, I mean, spacing for the configuration and the patterns of lighting. I mean, we have for the approaches, there's two basically for categorized for instrument runways, precision runways. We have the Barrett system, we have the Calvert system as a pattern, as a configuration. We have the spacings of runway centerline lighting, depending on the category of operation. We have the spacing of runway edge lighting. So I think here, Tony, there must have been a lot of work done on that spacing element, that configuration.
yeah. Indeed, if you're going to do R&D in this field, you need to have a background of the research that has been done that quantifies what a pilot needs to see and how he uses that information. And after World War II, when the civil world and the military wanted to move towards 0-0, and there were approach aids now, the ILS, had actually been invented in the 1930s. But they wanted to use this technology to enable aircraft to operate in much more restricted visibilities. The UK put a lot of work into doing this in autopilots and ILS systems, the integrity on them. But they had work on the visual aids aspects, because unless you go an absolute 0-0, you've got to have visual aids in there somewhere. And one of my predecessors, Ted Calvert, of the famous approach lighting system, he did a lot of work using what were then pretty rudimentary simulators, and by talking to pilots and actually demonstrating to them what they actually used the lighting patterns for and how they use them and what would be a useful pattern. For example, he showed that actually flying an approach on a curved pattern of lights on the ground is not very easy. You want straight lines. You basically your pattern should be straight lines, vertical and horizontally, as it were. Curved patterns, funnels, and things like this that people approach. The funnels of lights that will guide you. He showed that those cues weren't nearly as good as basic the patterns that he amongst others, but he very much came up with the patterns we now have, which really haven't changed. But as far as the spacings were concerned, again, that came out of the Calvert work. They demonstrated that, originally no centerline, of course, it was just edge lighting. And it was how many lights you need to be able to see to steer straight on the runway, for example, takeoff. Experimental work that came up with figures of 100, 200 feet. I did some work actually looking at actually for the military on a very rudimentary strip. I demonstrated in good visibility, you could land very sophisticated airplanes, fast fighter jets and Hercules aircraft and things like that on a 50-foot wide strip, 4,000, 5,000 feet long, with a light only every 1,000 feet down the edge of the runway. Perfectly feasible to do it. But as soon as you get into lower visibilities, of course, you have to have more. And that's where the category 1, they came up with the specifications really for the threshold and the runways. When it came to centerline, there was quite a debate about the spacing that would be necessary. A lot of the fog flying defined the specification in terms of decision height and runway visual range were based on flight trials that were done by the FAA and also very much by us at Bedford, where the centre lines were actually 100 feet spaced, 100 foot space, 30-meter spacing. There was pressure from some thinking that for low visibilities, we ought to have it half that and have lower intensities. Well, that was a false. I did some trials not long before I retired in simulation to show that 100-foot spacing on the centre line is perfectly adequate, provided it's maintained, not only for landing, but the most demanding case the flight was not the centre line on the runway for landing. It was takeoff when you had a need to abort the landing near V1 where you should rotate. But instead of taking off, you've got to bring the runway, the aircraft to a full stop. That's the most demanding cue in terms of following the centre line that pilots identify. It isn't perhaps what you'd think, but that's where it is. You know, you need this background to understand when you do things and why you change, and why we were able towards the end of my time working the Vision Age panel, again from research we did to show that we could take the existing patterns in NX 14, we could produce the patterns with fewer lights. For example, in the approach, the side barrettes, the red barrettes, 80 red lights there. You could halve the number of lights and get the same performance. We could reduce the number of lights you actually need. The only criteria was those lights must meet the specification. And Annex 14, and certainly the CAA does allow that possibility that you could produce the patterns with fewer lights, provided you meet the requirements for intensity and beam spread.
The sad thing about it, Tony, that the airports around the world interpret that requirement of reducing the number of lights. For example, the red, side row barrettes, as they're called in the FAA world, and the supplementary approach lights, and then including the touchdown zone lights, where they halve the number, but they say, oh, but that's allowed without demonstrating compliance.
Yeah, well, that's
the sad thing. What
dangerous.
Yes.
So, gentlemen, we're now 20 past. So I think we need to pull the curtain down. There's a lot more questions which we will answer as usual through our website. I think you just illustrated the importance, and the great thing for the audience there is that each one of you has spent an enormous amount of time in battle, actually at airports, have a great deal of personal experience and are able to talk with such authority on all of these topics and understand in detail the environment that we're working in. So thank you again for your contributions today and everything you've contributed to TMS over its 40 years to date. And let's look forward to the next 40 years and hope we continue with the success we've enjoyed in that time to continue to bring knowledge, products and services and to benefit the aviation world in the years to come. So thank you very much to Tony Smith, to Stuart Ford, Keith Costa, and of course Felicity and Damon, who've put everything together for us today, for your contributions today, and of course to the audience for joining us, and without which none of this would be possible. So thank you very, very much, and I look forward to seeing you all for the next webinar, where we're continuing to talk about the measurement of lighting and the use of analytics in the maintenance of the visual aids at your airfield, following on from the previous webinar by Rob Billingham, who will bring you his insightful knowledge and understanding of analysis and measurement, to bringing to the fore our old adage, you can't manage what you don't measure. So thank you very much, everybody, and I'll see you all in a month's time, last Tuesday of July. Thank you very much and good night.
Thank you.
Right.
Bye.
Bye-bye. Thanks.